And so here we go. So we're starting with a term here. Find the degree. Okay, so let's talk about what degree of a term is. If you have something like, let's say, 7x squared, the power is the degree. The degree is the power on x. So the degree of a polynomial is the power, well, let's do it. Let me change that a little bit. It's the highest power. The degree is the highest x power.
Degree is the highest grade.
Highest x power. So look down at this one, for example. Look at that one right there. Let's just jump to the hardest one, then the easier ones will be really easy. So look at that. That one has 4 different terms, doesn't it? It has a 3, a minus 1x to the 6th, a plus 2x to the 4th, and a plus 4x to the 7th. So what's the degree of that polynomial? 7, exactly. Because that's the highest x power. Does that make sense?
Oh.
So it's just the highest one.
Wait.
So let's count.
So on the polynomial, we're looking at the greatest square.
So I'm looking at all these right here. And I'm just looking at the power. And just taking the biggest power there. That all good? So the biggest power is the degree. All right, good. And then how about this one right here? What's his degree? 7. There's just only one of them, huh?
Yeah, I knew it was a lot easier. I just was making it hard.
And what about this one? What's the degree of this one? Just 4. Just the power.
And 1.
So this is 6. Now, the last one's a trick.
0. Because the power of a regular 3 is 1.
Okay, now careful.
Wait.
Highest
Power. Oh.
x power. That. Right? Now you think, well, there's no x at all there.
0.
Right. Could I write it 3x to the 1 like that? And that would be the same? No, huh? That wouldn't be the same. 3x is not the same as 3. So we can't do that. That's not the same. Remember in math, we often make things look different without being different. Well, how could you write an x power and have it really be the same?
You have to make it into
X to the 0.
Yeah.
Remember what we learned last time?
With the parentheses.
Remember anything to the 0. What's 7 to the 0 power?
1.
What's 3 to the 0 power? What's 1,517,263 to the 0 power?
1.
Anything to the 0 power is 1, right? So I could write x to the 0, and that's the same thing. 3 times x to the 0 is the same as 3 times 1, right? Because x to the 0, or anything to the 0 is 1. And 3 times 1 is what? The same as 3. So long story short, a plain 3 is the same as 3x to the 0. So what's the power on the x? 0. When there's no x at all, the degree is 0. That making sense?
Yeah, but on the homework assignment, there's a question on there that says, find the degree of -2. And when you try to put the thing in to put 2 to the 0, it won't do it.
No. So for -2, what's the degree? The degree is the power on the x.
Right.
There ain't no x there.
Right.
So the degree is
So it has to be 0.
just straight 0.
Oh,
No.
okay.
Just straight 0. Yeah, you don't do anything with the -2.
That's why I was getting it.
It's just straight 0. Good, all right. Come on down. Let's subtract polynomials on this one. So we want to subtract 2 polynomials. Let me, I don't know if you can see. Can you see that very well? We all see that okay?
Yeah.
So what do we do when you have a minus between 2 parentheses like that?
You need to distribute the negative.
Exactly. Yeah, this minus sign is going to go boom, boom, and boom. Does that make sense on that? Goes to all 3. So anything up against the wall of a parenthesis distributes to everything in that parenthesis. Distribution, that's like what I'll do when I come with the test next Thursday, is I'll distribute 1 to everybody, right? That's what the negative is going to, anything in front of a parenthesis passes himself out, distributes himself to everything over there. So that'll become what? Negative 6y squared minus 2y and plus 9. Changes all the signs, doesn't it? When a negative hits those guys, it changes their signs. How are we doing? Is that making good sense? Now, what about this first parenthesis? Is there anything in front of, right here in front of the parenthesis? No. So then you can just drop off the parentheses and bring it down, no changes. Does that make sense? So again, when do we drop off parentheses? Well, after we distribute anything that was in the front, If there's anything in the front of parentheses, you go ahead and distribute that all the way through, and then you drop off the parentheses. So parentheses always vanish after anything in the front goes in. That's when they drop off. And on this first parenthesis, there was nothing in the front, so we just dropped them and there was no change. Is that good so far? Mm-hmm. And now we do like terms. Remember like terms? So the y squared with the y squared. Just combine like terms there. So 5y squared, take away 6y squared. Yeah, negative 1y squared. Good, just 5 take away 6. And then minus 8y and minus 2y. So the y squared combines with the y squared, and the regular y will combine with the regular y.
Wait.
So now think about, if you have any trouble with positive, you can use calculators, of course, on everything, homework tests and everything. But if you have any trouble at all, just think about money. Positive is like a gain. We all deal with money, right? Positive is like a gain, negative is a loss. So negative 8y is like losing $8, and negative 2y is like losing $2. So if you lose 8 and you lose 2, how's your bank account?
Negative 10.
You're down 10, aren't you? So you know what to do.
Did I just miss something when I blinked? You said 5y minus 8y?
So 5y squared minus 6y squared, right?
Okay,
They're the ones that are the like terms there.
Yeah.
So that's a gain of 5 and a loss of 6, so it's negative 1. And then the last one's negative 6 and plus 9. If you lose $6 and gain back 9,
Plus 3.
you're plus 3. And there we go. That's all we got to do. You remember that kind of? Like terms and all that stuff on that? Yeah.
Are we simplifying?
Number 3. So number 3, minus 5a to the 6th plus 6a to the 5th plus 9a to the 5th minus 9a to the 6th. So this one has plus between the parentheses. So really, you could just drop off the parentheses. They're not doing anything here. By the way, how do we know that the parentheses don't mean times? Because sometimes parentheses mean multiply,
Because there's a plus and a
Exactly. Everybody good with that? Dennis is exactly right. If there was nothing in the middle and the parentheses were right up against each other, that would be multiply. We'll do some of those, I think, tonight, pretty soon, in just a couple minutes. But if there's a different symbol in the middle, like plus or minus, then we just do that. It's not multiply, right? And so, yeah, we can just drop off the parentheses. They're not really doing anything important. This time there's not a minus in front like there was on that last one, So we're not going to change any signs. You with me? Now you might say, well, I hope I'm not confusing you. You could say, well, Mr. Aaron, shouldn't we distribute that plus sign? Okay, sure, if you want to. It's not going to change anything. That's why I don't even mention it. But you totally could. That's true. Positive times 9 is still positive 9, isn't it? And positive times negative is still negative, isn't it? See, nothing changes. So when the plus sign's in the front, nothing changes. Same thing on the other one. Just bring these guys down. No change at all. Minus 5a to the 6th plus 6a to the 5th. We good there? And now we combine like terms. So, like minus 5a to the 6th. Which one is the same as him? Which one is like terms with him? Yeah, the ones that have the same. Well, wait, I'm confused. Not those two. These two, Yeah, the ones that have the same powers. So like terms are the ones that have the same powers, and then you just add the numbers in the front. Negative 5 and negative 9. So if you lose $5 and you lose $9, how's your bank account? That's what happens in Las Vegas.
Yeah. Unless you're doing homework.
That's right. That's right. And the other two, these are like terms. 6a to the 5th and 9a to the 5th. Yeah, 15a to the 5th, right? If you gain 6 and gain 9, you gain 15. Like that. Does that make sense? That's a really good question. Yeah, the order doesn't matter, but the signs in front do matter. Do you know what I mean by that? Sabino, right? Sabino? Yes. Yeah. So in other words, I'll say or. So again, everybody here, let me say that again, then let me write it first, probably be more helpful.
Yeah, because I just missed it because I didn't put it on the right.
Yeah, it's the signs that matter, not the order. Yeah. So in other words, either one of those answers is totally good, and the program knows it and will give you credit. Notice, the order doesn't matter, but the signs in the front matter. So you can move them around all you want. This is always true, not just this particular problem. This is always true in all of algebra for things added and subtracted. You can move them around however you want as long as you keep the same sign in the front of them. Now, what do I mean by that?
Negative and positive.
Yeah, I mean, like, what's on the 14? A negative sign. So what's on the 14? Same negative sign. What's on the 15? Positive. What's on this 15? So it's all good.
And if you put a negative, like I actually dropped that negative 14 by accident, and I got a totally different answer.
Right. Yeah. So you got to have the right signs. Order doesn't matter. Good question.
But I mean, you need to put the positive sign when there's just a regular number.
Oh yeah, no, you don't. Good question. Like this one?
Yeah.
Yeah, not needed. Totally. Yeah, skip it. You're right, Sabino.
But it does save you before you turn in your assignment.
All right, try that one. So you know what to do with that minus in the middle, right? You're going to distribute it to the right. On track. I'm glad to help as well. All right, so I'll bring them down. And then that minus is going to change all the signs there. So minus 5x to the 5th, minus 7x squared, plus 5. See how all three signs changed on that? We good? And now, let's combine like terms, huh? So x to the 5th minus 5x to the 5th. So what's that going to be? Yeah, what number is really right here? Like Miguel and I were talking about, what number is really right here? 1. Oh, so I said the wrong thing. I didn't look closely. It should be 1 minus 5. So if you gain 1 x to the 5th and lose 5 x to the 5ths, how's your bank account? Down 4.
X to the 5th.
X to the 5ths.
Which is a lot of money.
And then minus 9x squared and minus 7. If you lose 9x squared and lose 7 more x squared,
subtract or adding if you want to be different.
yeah, you know that they actually add up to be a big old loss.
Yeah.
That's what really happens in Las Vegas.
Tricky stuff that if you're not wise, you'll get caught. Because the last two are not equal. So
Exactly. Good eye, good eye. So these just drop down unchanged, huh? Because they are unlike terms.
Making math funny.
Is that making sense? Questions I can answer on all that? Is that good? Yeah, so notice over here we put a 1 in front of that. There's always invisible 1s in the front if there's no other number in the front, isn't there? Because there's one of those.
What are you talking about?
I'm talking about that x to the 5th here. So if
Oh, yeah, I got you.
Yeah, so if we just have x to the 5th, that really means 1 x to the 5th. Yeah, very good, very good. Good.
Oh, I see what because you might get confused
with this other one.
Minus 4, yeah.
Yeah, 1 minus 5, yeah. That's right. Good. Good. Okay. Let's see where we're at.
We got to switch papers.
So to number 8, x plus 4 squared minus x plus 7 squared. All right. So what should we do on this one? We've got to realize we got to FOIL out that first part and FOIL out that second part. What do I mean by FOIL? I mean the 2 means 2 of them, huh? So it means x plus 4, x plus 4. And this other one means x plus 7, x plus 7. And then we have to like multiply out that first one. And how do we multiply it out? It's the first goes to both, second goes to both thing. Do you remember that? Yeah. So this first one goes to both of those. And the second one goes to both those. And then we have to do the same thing on the other one too. So there's going to be 4 multiplications. That's what you always do when you multiply 2 things with 2 things, right? The x and the 4 with the other x and the 4. 2 things with 2 things. They call it FOIL, sometimes F-O-I-L. That's another good way to, I'm just going to say first to both, second to both. It's the same. So here we go. So this x, he's going first. He's going to multiply both of the other 2. So it'll be x squared plus 4x, and now he's done. Everybody see what happened there? So x times x made x squared. See, they have invisible 1 powers, remember? And those powers add to be 2. So remember when you multiply things, the powers on the x's add. Okay, now he's done, and now it's the 4's turn, the plus 4, and he's going to go to both. So it's plus 4x, and 4 times 4, 16. So I'm done with the first one, minus, and now I'll do the second one in the same way. So first to both, second to both. And now for the second one, same thing. First to both, that x will go to both, and then the 7 will go to both. First to both, second to both. So it'll be x squared. Now, you see this? One thing I should say. Do you see this subtraction symbol? He's going to change all the signs of this guy. Remember, like, look back at the last problem. See how this minus sign here changed all these signs? So a minus sign in front of some parentheses stuff always changes all those signs. So as we go, I'm going to have to change all the signs. So it'll actually become a minus 7x. And now the 7's going to go to both. But the minus hits it as well. There we go. And then we still have to do a little bit more gathering. But did you track with that? So in both cases, I just did first to both, second to both. Same thing here. First to both, second to both. And then the minus subtraction had to hit them all. Like it always does when it's in front of parentheses. It hits everybody, huh? Okay, now the parentheses are gone, right? The parentheses always drop off once we multiply them, don't they? So now we can just go into like terms. So x squared cancels x squared. Those drop out. They just cancel out right there. Is that good? And now let's gather the other terms. So 4x and 4x is 8x. Minus 7, just think about money again. So 4 and 4 is 8. Minus 7x is 1x. Minus 7 more x, negative 6x. Did you track with all that? So just think about money, right? 4x and 4x is 8x. Minus 7x leaves 1x. Minus 7 more is minus 6x. And you use calculator for all this stuff, even on the test. And then 16 minus 49, what is that? Minus 33. And we're done.
So the tests are multiple choice?
Yeah. It stands for FOIL. It stands for first, outer, inner, last. So that's the other way you can think about it. Meaning the first one here times the first one there. Here, it's all scribbled up now. Let me put it back the way it was. Yeah, the other way you can think about this is FOIL. It's the same thing as what I'm saying, first to both, second to both. It's all the same. So in other words, the first one here times the first one there. And then the next one comes from the 2 outers. The next one comes from the 2 inners. And then this one comes from the last times the last. That's the other way. FOIL. It's the same as first to both, second to both. 2 ways of doing the same thing. There's our answer. Questions on that one? Squared. So that's nice. It's just one of them instead of 2 of them. That'll be a little easier. So you know what to do right away, right? Write 2 of those parentheses and multiply first to both, second to both. So whenever we have a 2, that means there's 2 of them. So that's first, and now go ahead and do what we did last time. doing well. So this first one will go to both, right? So 4 times 4 is 16, and 4 times 7 is 28. So first to both, and he's done, huh? And now it's the second. Now remember, when you take this 7x, that negative sign really belongs to him. In fact, it might be more helpful to you. Let me show you how I rewrite it. Sometimes it's helpful. I stick these signs right on that guy and right on that guy. That's really where they go. You know, when they separate, that minus goes on the 7x. Remember, signs go with who they're in front of. So that might help you to rewrite it that way. So now this minus 7x is going to go boom, boom. To both those get minus 28x. And minus 7x times minus 7x, two negatives, positive 49x squared, right? Because the invisible 1 powers on the 2x's add. Good there. And now these two in the middle. So now the multiplying is over. The parentheses are gone. And I change gears into adding, subtracting mode. Did you hear all that and catch all that? So when the parentheses were there, I was multiplying. But as soon as you multiply, there's no more parentheses. And you change modes into adding, subtracting now, huh? And in adding, subtracting mode, it's just about like terms, isn't it? So just these two in the middle. Yeah, you just use your calculator or by hand. Yeah, if you lose $28 and lose $28, you lost $56. And there we go.
Wait, how did you get the 49?
7x times 7x. Yeah, so what I did back there is I did first to both, second to both. So one more time, I took that 4 and I went to both of those two. 4 times 4 is the 16 and the 4 times 7 is the 28. And then he was done. And it was the minus 7x's turn. They take turns. And he went to both. He made the minus 28 and then the 49x squared at the very last multiplication.
Oh, it's because like I subtract on the calculator and do it wrong.
Yeah, they're multiplying. It's all multiplying. Yeah, on that. Is that good? Makes sense there? Questions? All right. Let's keep going. Yeah, number 10 looks good. Definitely do number 10. It's a tough one. 10 says x minus 4 x squared plus 4x plus 2. Okay, so this is the same thing. Let me guide you through it a little bit. This x is going to go to all 3 of those. And then when he's done, the minus 4 is going to go to all 3. Does that make sense? They just take turns, don't they?
Yep.
And let me scoot that minus right on the 4. So we know that's really where it goes. So give that a try. So the x goes to all 3, and when he's done, the minus 4 goes to all 3. You should have 6 multiplications, right? And then gather your like terms. Now remember, this first x has an invisible 1 power, so it'll add. So it'll be x cubed plus 4x squared, because that other x has invisible 1 power. Remember, there's invisible 1 powers that add, plus 2x. He's done, right? He went to all 3. And now it's the minus 4's turn to go to all 3. Minus 4x squared, minus 16x, minus 8. 6 terms altogether. First to all 3, second to all 3. And now the multiplying's over, the parentheses are gone, and now we'll gather like terms. So let's do that. So let's start. I usually just start at the highest power and go on down. X cubed. He's a one of a kind, huh? There's no other x cubes. So he'll just stay himself there. What happens with 4x squared and minus 4x squared? They just drop out, don't they? And then 2x minus 16x. If you gain $2 and lose $16,
Negative 14.
your bank account's minus 14x. And finally, the minus 8. Notice how I cross them off, circle them, whatever, underline them, just so you know if you've don't lose any. Yeah, Miguel. Yeah. Okay, so let's try number 11. So it's going to be, In fact, you know what? I'm going to change it to x's and y's because my u's and v's kind of look alike, and you'll get confused. So let me just make it. It's the same thing. I'm just going to make it x, y's instead of u's and v's. There we go. So try that one. Same kind of thing. The first x is going to go to all three. And then when he's done, the negative one, I'm going to put that minus right on the y where he belongs. He's going to go to all three. Now remember, when you multiply, all those letters have invisible 1 powers, don't they? Yeah. Go ahead and I put the ones on there. And when the same letters multiply, the powers happen here. So we're going to take, so when this x hits x squared, the 1 power and the 2 power add x to the third. And then when this x hits xy, x squared y. Perfect. Because the 1 powers added on the x's, huh? This little 1 and that little 1 added up, didn't they? And then when the x hits the y squared, that's just xy squared. He's done. Now it's the minus y's turn. Keep going. All right, so we're good so far. I want to make sure that you see what I'm doing. I'm taking that first one to all three. I haven't done the minus y at all yet, right? I take the first to all three. And as he goes, you add the powers, right? So when x1 hits x2, that's x cubed. When x1 hits xy, that becomes x squared y, right? The powers add. We good so far? Now it's the minus y's turn. So now I'm going to take this guy and go boom. What's that going to do? Minus x squared y, right? Because they're not the same letters, so the powers can't add. And then boom to the middle. That'll be minus xy squared. The 1 power in the y and the 1 power in the y added. And then all the way to the back. That'll be minus y cubed. Good?
So the person who has the square or the power is always going to go first.
I just take the very first one in the parenthesis and go to all three, and then the second one and go to all three, regardless of any other power considerations. Okay, now the multiplying is over, right? We're done multiplying. No more parentheses. We're in adding, subtracting mode. When you add and subtract, remember it's only like terms, meaning same. What's a like term? Same letter pattern. Same letter pattern. So x cubed, is there anybody else that has that exact letter pattern? No. So he's in a class by himself, x cubed. How about x squared y? Does anybody else have that exact same letter pattern?
Yes, there is.
This one, and they cancel, huh? How about xy squared? Does anybody else have that exact same? Yeah, and they cancel. Minus y cubed.
Yeah, I had to write it bigger.
Good question, because you're saying you wrote minus yx squared, right? Let me ask you, is 2 times 3 any different than 3 times 2? What's the answer to both of them? 6, right? So if the order of numbers multiplying doesn't matter, a letter is just a number I don't currently know. That's all a letter is a number we don't currently know. So if the order on numbers doesn't matter, then the order on letters doesn't matter. So you could write it this way, that's fine.
When canceling out, it wouldn't matter? It would, right? No? Like when you're trying to cancel out negative y squared, you
Okay.
would be able to cancel it with the person.
Yeah, because in other words,
They are the same. So however you write it, know in your mind they are the same.
yeah,
And thus you can cancel them
and
out.
that's what I did wrong.
Does that make sense?
One I wrote xy
So-
squared, and the other one I wrote y squared x.
Yeah. So, which is fine, but they are the same. Is that making sense? So just like if somebody said, yeah, I had 2 times 3. Why am I scribbling so much? I had 2 times 3, and I tried to subtract 3 times 2. Yeah, 0. Right? Even though the order's different, they are the same, aren't they? So it's fine. You can write now. If you want to know typical procedure, we normally write them in alphabetical order just to make life easier. But you don't have to. So normally, x comes before y in the alphabet, so we would put the x first. That's typically how it's done, just to make things easier to look at. But you don't have to. The order doesn't matter But you need to know they're the same so that you'll know to cancel them out. That good?
But if you do it in alphabetical order, you won't make a mistake.
Yeah, that might help. Other questions on that one? Here's number 13. Let's try that one. So you need to multiply out those first two parentheses and then combine with the stuff at the back. All right, are we ready? Boom, boom. So this first one goes to both. I'm going to fix these signs just to make it more clear. This minus is right on that 6, isn't it? So that first one goes to both, and so we get 42x squared plus 14x. And he's done. Is that good? And then the minus 6 goes to both. Minus 36x minus 12. Is that good? And then just bring down the stuff on the right side, plus 5x minus 3. How we doing?
And then combine like terms.
Okay, so now, now we're going to, so the parentheses are gone. I multiplied. Now combine like terms. So 42x squared, he's in a category by himself. Next comes all the regular x terms. So that would be this guy, and this guy. And you could just add and subtract the numbers on your calculator if you want. Plus 14 minus 36, like that's minus 22. Plus 5 is like minus 17, I think.
Yep. X.
Minus 17x.
And then the 3 is by itself.
Minus 12 and minus 3.
Negative 15.
If you lose $12 and lose $3, you lost $15. All right, let's try. I'm going to jump in. So I'm going to put this 2 minus right on the 2. That's his minus sign, right? So that 5x goes boom, boom, boom. Use your calculator. 5 times 25, 5 quarters? $1.25, right? X cubed? Because that's x1 and x2 powers add.
3 slices of pizza.
And then 5x multiplies 10x. Remember, out front numbers multiply, powers add, huh? 5 times 10 is 50. Powers add, invisible ones to make 2. And 5x times 4, 20x. Out front numbers multiply, powers add. So the 5x is done. He went to all 3. Now it's the minus 2's turn. He's going to go to all 3. Minus 50, x squared, minus 20x, minus 8. We good there? The parentheses are gone. The multiplying is over. We change modes, and now we're going to add, subtract. So when it comes to adding, subtracting, it's all about like terms, same letter pattern. So 125x cubed, he's in a class by himself. Bring him down. Right? Next, 50x squared cancels that. Oh, and the 20. Oh, that's so nice. There it is.
Did you know that when you put that together?
I didn't.
Oh, okay.
No, I just realized it just now. I'm not putting on. I was surprised. 16. Let me do this one with you. 16 holds a challenge. So how are we going to do this one? That's a good idea. Yeah, let's just do the parentheses. So just let that 4x just kind of chill there in the front. And multiply out those parentheses at the back. Exactly, good idea. So I'll let you do that. So go ahead and multiply those parentheses. The 3x plus 5, so that 3x will go to both. And then the 5 will go to both. Do all of that, and just let that 4x wait his turn. When you're all done with the inside of the parentheses, then the 4x will distribute, multiplying everybody. All right, so doing that inside there, it's going to be 3x times x. Out front numbers multiply, powers add, don't they? x1, that'll be 3x squared minus 6x. So that 3x is done. He went to both, and then plus 5x minus 10. Now it's the 4x's turn from the front. He's going to go boom, 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 boom. You could combine the minus 6x and the 5x in the middle first, or you could just do it after. It'll work either way. I'll just do it all right now. So you could.
You mean the minus 6 and the 5?
Yeah, you could combine those first if you wanted.
Yeah, I was curious about
Either way.
that. Would it matter?
It wouldn't matter. Either way, it's going to come out the same. So I'll multiply the 4x through there. Now, as that 4x multiplies, out front numbers multiply, powers add, right? 4 times 3 is 12, x cubed, because that 1 and 2 add, minus 4 times 6 is 24, x squared, right? Out front numbers multiply, powers add. 4x times 5x plus 20, x squared. The invisible 1 powers add. The 4 and the 5 multiply in the front. The invisible 1 powers add. 4x times negative 10 minus 40x. We're almost done. Now these two are like terms. All the multiplying's over now. Now we're in the final adding subtracting phase. Those two are like terms. So we can combine those two.
Or we could have simplified it back then for
Right, either way.
1.
So minus 24. If you lose $24 and gain back 20, you're down 4, aren't you?
What's easier because doing the whole entire thing out seems easier. Should we keep the way we've been going by the rules?
It's pretty close. It's pretty close. They're not much different. Yeah, if you had combined these two right here, you would have got minus 1x,
And
right?
of course, yeah.
And then 4 times minus 1
It's negative 4x.
would have been the same. Either way. Are we good there, though? Do you understand the main structure behind how you do one like that?
Now that makes sense why you want us to combine the stuff if we can, because we want to do extra stuff.
Yeah, that'll make less multiplications. Yeah.
But you got to be able to find it.
Yeah, it's true. So that 2x squared goes to all three. And when he's done, the minus 9x is going to go to all three. Keep going. All right, I'm going to jump in. Out front numbers multiply, powers add. So those are the first three. Yeah, then this, that's right, because this minus sign's really on the 9x, huh? So that minus 9x is going to go boom, boom, boom. So you'll get minus 27x cubed. Out front numbers multiply, powers add. Minus 27x squared minus 90x. Good. So Miguel reminded me, you could line things up. It does help a little bit. You don't have to. But like, see how that minus 27x cubed? You could just line it up underneath the other x cubed, because you know they're going to combine, huh? And then the minus 27x squared, right? Just bring him there and bring him there. Just line them up in the column with the stuff they're going to combine with, you know? Kind of keeps things organized. And then the minus 90x will be last. If it confuses you, don't worry about it. But it might help. Minus 90x goes there. So you see how we have an x squared column and an x cubed column. You know, x to the fourth, x to the third, x to the second, regular x, and then, you know, plain numbers. That helps some people, if you want. Keep things lined up. Hopefully I didn't just confuse you by doing that.
You did.
So those three blue terms are the ones that came from the minus 9x going to all three.
I mean, it makes sense how to do that, but the problem is when you start doing like that, you
might lose track. Yeah. So either way, whatever's easiest for you. So then this minus 10, I'm going to go to all three. We get minus 30x squared, so I'll put that in the x squared. And minus 30x and minus 100. And then we can just add, combine everything that's in the same column that way. So there's the 9 terms. Make sure you have those exact 9 terms. All right, and then we just combine them. So I'll just bring this down. 6x to the 4th right here. Plus 6x cubed minus 27. What's that? Minus 21. X cubed, right? Okay, if you gain $6 and lose 27. This one, 20 minus 27 is minus 7 minus 3. 7 minus 30 is minus 37. Minus, if you lose $90 and lose $30, you lost $120 minus 100. There it is.